We will use these 5 equations to express the concentration of solutions. We have 4 problems in this video. So we have a carbonated drink here that contains sodium, and according to the nutritional facts, it contains 4 milligrams of sodium per 100 gram of that carbonated drink. So the density of the carbonated drink is measured. It's here. And also, this information is also relevant. As you can see here, 4 milligrams of sodium per 100 grams of solution. This information actually gives us the percent by mass of sodium. So directly from here, we can actually get now the percent by mass of sodium, which is 4 milligrams per 100 grams. So we need consistency in units. So it's either we express this in milligrams to have milligram over milligram, or this one, milligram to gram. So let's try converting 4 milligram to gram. And then this is the solute, sodium. And our solution, which is 100 grams in mass. So here the percent by mass of sodium is 0.004%. So the solution is 0.004% by mass sodium. Now, to obtain the concentration in grams per liters, or grams per cubic decimeter, by the way, 1 cubic decimeter is equal to 1 liter. And then also to express the concentration in molarity, we need the volume of the solution. So here we're given with the density. Alright, so the density of the drink, we will use this symbol to express the density. This is rho. So the density is 1.045 grams of the solution and 1 ml solution. So that means in 1 ml of the solution, 1 ml of that solution has a mass of 1.045 grams. Right, so given 100 grams of the solution, we will use this as our basis. We can get the volume because the formula for density is mass over volume. Right, so we will assume 100 grams as our mass. We have a density here. We can get volume. So volume is, here by the way, the mass is 100 grams, right? So volume is unknown. So 100 grams divided by 1.045, and we'll get, alright, so our 100 grams of solution, or 100 grams of the carbonated drink, has a volume of 95.68. We want to express this in liters because here our denominator is liters. 1 cubic decimeter is equal to 1 liter, and also here this should be in liters. So let's convert this ml into liters, which is easy because in 1 ml there is 1,000 liters, and our answer is 0.09569 liters of the solution. So now we can obtain the number 1. So by the way, the first thing we obtain here is percent by mass directly from the information. So here our solute is sodium, and we have 4 milligrams of sodium. So, but we need to express it in terms of grams. So again, we start with 4 milligrams, express it into grams. So this one will be cancelled. It's the same as this term, except for this one, we're not dividing by another mass. We're dividing by the volume of the solution, which is 0.09569 liters. Now our unit is here, grams per liters. So this is our answer for concentration expressed in grams per cubic decimeter or grams per liter. So we already have 2 and 1. So for molarity, capital M, molarity of sodium ion should be expressed in terms of mole of the solute per liters of solution. We already have the liters of the solution. How about the moles? So by the way, 4 over 1,000 is 0.004 grams of sodium. So here we need the solute to be expressed in terms of moles, so we need to use the molecular weight. So we have this formula. Moles of a substance is equal to the mass of the substance divided by molecular weight. So we have the mass of sodium, but actually here, since sodium is, we consider it here as an atom, so here, instead of molecular weight, we will use the term atomic weight. So the atomic weight of sodium in the periodic table, let's approximate it using 23 grams per mole. So here grams will be cancelled and we will get mole here, divided by the volume of the solution, which is 0.09569 liters. Or molarity. Molarity is also expressed as mole per liters. Okay, so moles of sodium per liters of solution. You can also use the capital M. Alright, so let's move on to the next problem. So here is the problem is a juice drink which contains this amount of moles of citric acid in 100 ml. Alright, so we already have moles. Okay, so here I can see it here. We have moles of the solute, which is citric acid, and we have the liters of the solution. The volume of the solution, which is in ml, we just need to convert this into liters and divide this by 1000. So 100 ml is equal to 0.1 liters. Alright, so this is the volume of the solution. So we will place it here. We will also place it here because cubic decimeter is equal to 1 liter. 1 cubic decimeter is equal to 1 liter. So we have our volume now, our denominator. So our problem is just the mass of this mole. So here we need to obtain the molecular weight of citric acid. So the molecular weight of citric acid, it is composed of carbon, hydrogen, and oxygen. The atomic mass of carbon is 12, hydrogen 1, oxygen 16, and the number of moles in... So in 1 mole of citric acid, how many moles of carbon is present? There's 6. There's 8 of hydrogen. There's 7 of oxygen, times. So the total here per element is 192 grams per mole. So citric acid has a molecular weight of 192 grams per mole. So here, to convert into mass, we can use this equation. So we want to obtain mass. We have to multiply the moles by the molecular weight. So transpose it here. Right, so the mole is 4.04 moles of citric acid. Moles of citric acid and times the molecular weight. Grams of citric acid over 1 mole of citric acid. So 1 mole of citric acid has a mass of 192 grams. The mass is 0.77568 grams. Alright, so this is the concentration in grams per liters. Alright, so we have number 1 now. How about number 3, molarity? To obtain molarity, we already have moles here. So mole per liter, moles of citric acid per liter of solution. Or you can also write it this way, 0.0404 capital M of citric acid. Alright, so this is the answer, number 1. This is the answer, number 3. So we have another problem. At 20 degrees Celsius, the solubility of ammonium chloride is 37.2 grams in 100 grams of water. So we want to express this solution, the concentration of this solution in terms of molality. So the unit here, number of moles of solute per number of kilograms of solvent. So number of kilograms of solvent, our solvent here is water, and it is 100 grams in mass. We need to convert this into kilograms. Just divide this by 1000 grams over, in 1 kilogram there's 1000 grams. So this is 0.1 kilogram of the solvent, which is water. Now number of moles of solute, again our formula, N is equal to M over molecular weight. So what's the molecular weight of ammonium chloride? So here 1 mole of ammonium chloride has a mass of 53.5 grams. So this is the molecular weight of ammonium chloride. We obtained it by adding the atomic masses of nitrogen, hydrogen 1 times 4, chlorine 35.5. So to get the moles of ammonium chloride, 37.2 grams of ammonium chloride divided by its molecular weight. So grams will be cancelled, and so it's 0.6953 moles of ammonium chloride. So now we're ready to express the concentration in molality. Molality has a symbol of small m. So the mole is 0.6953 moles of our solute divided by the kilograms of our solvent. So it's 6.95 mole per, so it's 6.95 moles of the solute divided by the kilograms of the solvents. We're done with number 4. How about number 5? So number 5, the mole fraction, we need to express both the solute and the solvent in terms of moles. So we have 100 grams of H2O. Let's express this in terms of moles. Alright, so to obtain mole fraction, we'll use the symbol XA here. Alright, so XA, particularly we're pertaining to ammonium chloride. So X NH4Cl. So here our solute 0.6953. And here, mole of our solute divided by mole of the solution. The solution is made up of the solute and the solvent. And the answer is this one. So molality, number 4, our answer for molality is this one. Number 5, our answer for mole fraction is this one. Let's answer the last one. Alright, so down to our last problem. The mole fraction of oxygen dissolved in water at 25 degrees Celsius is 2.3 times 10 raised to negative 5. So we have mole fraction here, and we have an equation for mole fraction here. Would that allow us to determine the mole fraction, the mole of solute and the mole of the solution or mole of the solvent? How? This given here relates to the equation for mole fraction. So we have the mole fraction of oxygen, which is our solute. So the solute here is a gas dissolved in liquid and dissolved in water, which is our solvent. So here basically our A in this equation is our solute A, and our solvent here is B. So the best way to tackle this problem is to assume that the total of the solute and solvent is 1. So we will assume that our total solution is 1 mole. And 1 mole of solution is here, is this one, is the sum of mole of A and mole of B. Again, mole of A is solute here, B is solvent. So we can just substitute this to our equation here. So the mole fraction of oxygen is 2.3 times 10 raised to negative 5. So it's here equal to mole of O2, and we assume that this is the mole of our solution, it is equal to 1. So that will allow us to obtain the mole of O2, which is 2.3 times 10 raised to negative 5. And then we just subtract this to 1 to get the mole of our solvent, which is water, 0.999977 mole. Okay, so this is our solute oxygen, this is our solvent. So our goal here is to compute the percent by mass of our solute here, oxygen. So to compute for the percent by mass, we need both of this solute and solvent to be expressed in terms of mass. Right, so the molecular weight would be needed here for our conversion. So molecular weight of oxygen gas is 32 grams per mole. Molecular weight of H2O is 18. What's the mass? We'll write the mass here. So 2.30 times 10 raised to negative 5 moles of O2 multiplied by the molecular weight. So the mass of oxygen with this amount in this mole fraction is 7.36 times 10 raised to negative 4 grams. And then let's do the same procedure for oxygen, for water. So this is the mass of water. So we now have the mass of the solute and solvent expressed in terms of grams. Now let's solve here the percent by mass. Percent by mass O2. So it is equal to the mass of the solute over the mass of the solution, which is the combination of these two. And we need to multiply this by 100, because if not, then that will be mass fraction. So the percent is 4.09 times 10 raised to negative 3% of O2. So by mass. Right, so this is the percent by mass of oxygen dissolved in water at 25 degrees Celsius. So there you go. Those are problems that we express the concentration in different units written here. So I hope you learned something in this video. Thank you for watching.